Okay, welcome back. This is the second section, the last section of second part of section 6.3, differential equations, separation of variables, and the logistic equation. My goal is in about 10 minutes or so to finish the last three examples, so let's dive in here. So the first thing we're going to do in this example on the bottom of page 2 is find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point xy. So really, it's the same technique we've been using the last couple days, with the exception of them not labeling, not directly identifying dy dx is equal to y over x squared. Since that y over x squared represents the slope of any tangent line or the slope of the original curve, then that means that y over x squared is the differential. So the first thing we're going to do is separate variables. So we separate variables by rewriting as dy over y, and then dx over x squared. And then we can think of it algebraically as dividing both sides by y and multiplying the dx over there. So we're going to integrate now that we have the variables separated, and this of course becomes ln of the absolute value of y. And over here, this is a power rule because this can be thought of as x to the negative 2, so it's 1 over x to the negative, or 1 over negative 1, x to the negative 1 plus c. And I'm going to call this c sub 0, as been the case the last couple of examples. You will see why later. So what we have is ln of absolute value of y is equal to negative 1 over x plus c sub 0. Just a little bit easier way to rewrite x to the negative 1. So now what we're going to do is we can exponentiate both sides of this equation, or we can rewrite it using the definition of a log. Either way, try to just mix it up going back and forth. So on this side, the e and the ln are inverse, so they undo each other, so absolute value of y. And then on this side, we have e to the negative 1 over x times e to the c sub 0, if we break these apart. E to the c sub 0 is going to be our new constant c, so absolute value of y is equal to c e to the negative 1 over x, just like this. So then what we can do is we can think of this, when we rewrite this, as y is equal to plus or minus c e to the negative 1 over x. Okay. So moving on, I'm going to take this point 1, 3, and I'm going to substitute it in for x and y. So 3 is equal to c e to the negative 1 over 1. So 3 is equal to c e to the negative 1. Well, 3 is equal to c over e, because e to the negative 1 is the same as 1 over e. If we multiply both sides by e, which is just a constant, we get our constant to be 3e. And we're going to, now this is, back up here, back down here is our general solution. But now we're able to solve for c, so that's called a particular solution. And that's another way we're finding the equation, the specific equation of the original curve. So let's go back to this guy down here. Y is equal to plus or minus 3e. That's our value for c, and then we have times e to the negative 1 over x. So what I did was coming back down here, I substituted in the 3e back in for c. Okay, and now, let's see, the question is, are we going to have the positive or are we going to have the negative? Well, we're going to think about it this way. The point 1, the x-coordinate of 1 has to produce a y-coordinate of 3. So let's see what happens here. We have y is equal to plus or minus 3e times e to the negative 1 over 1. So y is equal to plus or minus 3e times e to the negative 1 would be 1 over e. So y is equal to plus or minus 3. So we know we got to have the positive 3 because it's got to produce that. So we just want a positive in this case. So our final answer is y equals 3 e times e to the negative 1 over x. And that could be simplified. I'll let you think about how that could be simplified if this is e to the 1 and that's e to the negative 1 over x. Okay. Moving on to our final page of our notes for for section 6.3. We have a tremendously difficult looking and ugly looking equation here. We're going to dive right in. You have two terms basically for that differential, that term and that term. So the second term I'm going to move over to the other side of the equation by subtraction. And my goal is to separate variables. So let's see, I'm going to move divide both sides by negative e to the negative x squared. Divide over here by y, so I have x d to the x over negative e to the negative x squared equals, I'm going to divide this y over here, y squared minus 1 over y dy. Just like that. Okay, so a couple things happen here, a couple algebraic things. We learned about, and let me try to get my exposure down here a little bit. Just to focus a little better for us here. Sorry about that. Okay, you don't want to focus, do you? Don't know what's going on here, guys. Bear with me. There we go. We're going to deal with it. So on this side, we have x dx over negative e to the negative x squared. And you can remember, you know that if you have a negative exponent here, come on, work with me here. If you have a negative exponent in the denominator, you can bring it up. So we have x, and then we have a negative e to the positive x squared dx. And over here, we're going to divide both these terms because there's a single term of a y in the denominator. So we can think about this as 1 over y times y squared minus 1 dy. So we can distribute that 1 over y there, and we get y minus 1 over y dy. And here, I'm just going to leave it as x times negative e to the x squared dx. We are going to now get ready to jump into our integration. So we integrate this using u is equal to x squared, du is equal to 2x dx, 1/2 du is equal to x dx. Okay, so we have a 1/2, we have an e to the u, excuse me, negative e to the u, du, which becomes negative 1/2 e to the u, which is x squared. Okay, and now on this side, we're going to integrate y, which is 1/2 y squared, integrate 1 over y minus ln of the absolute value of y. And if we want to put our plus c, we put on that side with the x, the dependent variable, excuse me, independent variable, 1/2 y squared minus ln of absolute value of y. And so here is what we have. Still pretty ugly looking. What I might suggest at this point is to plug in our point, which we are given as 0, 1. So let's go over here and plug in 0, 1. So we have negative 1/2 e to the 0 squared plus c equals 1/2, and my y is 1 squared minus ln of just 1. The absolute value of 1 is 1. So e to the 0 squared, e to the 0, so that's just 1, so negative 1/2 plus c. 1 squared is 1, this would be a 1/2. ln of 1 is 0, and so we get something that looks like this. Add 1/2, we get nice c is equal to 1. So I'm going to go back here and rewrite it. Negative 1/2 e to the x squared plus 1 is equal to 1/2 y squared minus ln absolute value of y. And I think at this stage I'm going to call it and leave it in this form for now. Just some, I think tremendously difficult algebra question there, but I think just the practice up here with the integration and the substitution is good for us to go over. And now we finish up the notes with a fairly simple, straightforward differential equation. dy dt is equal to negative 5y. So the only thing difference here is the independent variable is t instead of x. So let's separate. dy over y is 5 dt. So if we separate, I'm going to move the y over here. dy over y is equal to negative 5 dt. We get a logistic equation here like we have several times now the last several days. So ln of absolute value of y is equal to negative 5t plus c. And I'm going to call it c sub 0. Great. Because now we're going to exponentiate both sides, or rewrite it from logarithmic form. And so that would be absolute value of y is equal to e to the negative 5t plus c sub 0. Break it apart. E to the negative 5t times e to the c sub 0. This quantity becomes c, so y is equal to plus or minus c e to the negative 5t. And let me just scroll down here so we can see what happens there. And this is a general solution because they did not give us an initial condition. So that concludes our notes from 6.3. A copy of the answers are also in the classwork section of Google Classroom.